Okay, so in this video, I'm continuing where I left off from ionic compounds, where we're going to talk about polyatomic ions. Um, so polyatomic ions are covalently bonded structures that have a charge. So they're a little odd in the sense of they don't look like normal ionic compounds, but the whole molecule acts as an ion. So it does act the same when they're bonding to a metal. So, anyways, common polyatomic ions, these are ones that I'm going to expect you to know. So, you have ammonium, acetate, carbonate, chlorite. Actually, I don't really care if you know those, but I'm going to put them there anyways. Cyanide. Let's see. Hydroxide for sure. Hypochlorite. Nitrate, nitrite, percolate, peroxide, phosphate, sulfate, and sulfite. So if you remember those, you'll be good. I'm not going to expect you to memorize all of the whole list, but like really if you know those, you'll be all right. Anyway, so I would highlight all those, so just pause, make some flashcards, do something. I might probably going to make a Quizlet for you guys, so you like with the structures on them, so you can memorize them, and then I'll post that to Canvas because I think that'll help you memorize them. Quizlet's really good instead of like taking the time to draw the flashcards. So I will do that for you, and I'll post the link on Canvas and on my website. All right, so polyatomic ions. Polyatomic ions, as I said before, they're covalently bonded structures that have a charge. They act as an ion. So they form ionic bonds. Now, naming with a polyatomic ion. So naming rules. Super, super easy. So name the substance on the left as it is on the periodic table. Let me write that in black. And on the right, so this is step 1. Step 2 would be name the polyatomic ion on the right. You don't even have to add IDE, it's already there. There is one exception to this. Okay, so your exception is ammonium because it's got a positive charge. So ammonium is going to act as the metal in this case, where it's got a +1 charge. I'll draw an example of that real quick. Look, if you had ammonium chloride, that would be, I'm not going to draw the Louis dot structure, but wow. So that would be the example of ammonium chloride. Not too complicated, but that's the only time that I've seen where it'll be on the left. But usually the polyatomic's going to be on the right because they're mostly negative charges because they come from acids or they're losing an H or whatever. That's way beyond what we're talking about right now, so I'm not going to get into it. And that's really the rules for naming a polyatomic ion. It's not too different. It's pretty easy. So the next video, we're going to talk about transition metals, and then I'm going to go into covalence. So if you have any questions, please reach out to me, and I will see you in the next video.